Hello everyone, my name is Andrea Gonzalez and welcome back to my channel where we discuss very difficult, academic and hard to read articles about supply chain management. On today's episode we are going to talk about reverse logistics. Yes, that's right, a very trendy form of logistics nowadays. However, not everybody seems to know about it, especially the multinational companies. The article that we are going to discuss today is called Designing a Sustainable Integrated Forward/Reverse Logistics Network. But first of all, I think it is important to understand what reverse logistics is. So, the definition that appears on the article says that it is a process in which a manufacturer systematically accepts previously shipped products or parts from the point of consumption for the possible recycling, remanufacturing, and disposal. But to put it in a much easier way, reverse logistics is the process of moving goods from their final destination for the purpose of capturing value or proper disposal. But in order to not go so far into each definition that comes in the article, today we will focus on the problem that is mentioned, the solution, and a brief conclusion. So, the article mentions that governmental regulations and the pressure of non-governmental organizations have convinced corporations to consider sustainable issues in their decisions. This may not sound like a problem, but it is the reason why the authors came up with a solution to address those issues. The authors of this research paper are Hamed Farroki, Ahmad Makui, Rosbeh Guzzi, and Masoud Rabbani. So, you may be asking, what solution did they develop? Well, the creation of a simultaneous design of forward and reverse logistics, presenting a new multi-objective mathematical model that takes into consideration economic, environmental, and social issues. But before we get into that, let's clear out what was the process of getting into a hybrid model. Obviously, the authors knew that they had to consider sustainability as a part of the process, and one of the systems that really implements that is the operations management system, because it considers the 3R concept: reduce, reuse, and recycle. Now, reverse logistics is one of the most essential parts of the operations management, because big part of its definition includes the 3R activities, but also consider business and environmental factors, which both would include benefits that are gained from using applicable material or parts in the production process and decrease environmental crimes by governments. The designing of a network involves various decisions that must be made in different managerial levels like strategic, operational, and tactical levels. That is why forward and reverse logistics should be considered integrally, since reverse logistics has a great influence on the performance of the forward logistics and vice versa. The reverse logistics network that the authors present is pretty complete and, according to them, and I quote, is a closed loop. To explain it a little, the reverse logistics strategy starts when returned products are collected from customers' area to the location of opened collection centers. Then, the recoverable products are shipped toward production/recovery centers, and then the recovered products are added to the forward logistics. So, the recyclable and returned products are shipped to recycling centers, and scrapped ones are shipped toward disposal centers. Combining relevant centers offers cost saving to the whole system, which is an objective of this new model, and another objective is to determine the volume of CO2 emitted in the network and the trade-off between the total costs. That is why this research paper aims to consider social issues by taking the effects of undesirable facilities, like recycling and disposal centers. Therefore, the authors came to an agreement to design a multi-objective integrated forward and reverse logistics, in which the network includes production/recovery sites, distribution centers, customer zones, collection centers, recycling facilities, and disposal centers. However, the decisions of opening these facilities should consider the level of capacity of each one, and the level of investment in environmental issues. In previous researches, there have been single objective optimization models, but the problem with those is that they are usually aimed to reach the optimum or rational solutions. That is why the authors based their model on an already established one, called non-dominated sorting genetic algorithm, or NSGA2. The model created by the authors is called a multi-objective hybrid genetic algorithm and simulated annealing algorithm, aka MOHGASA. But let's just call it MOGASA for the purpose of this video. This model is developed to solve the sustainability integrated forward/reverse logistics network design. And after some tests, the performance of the proposed hybrid algorithm is compared with NSGA2, and the associated results are analyzed. The results showed that the average performance of the MOGASA is better than simple NSGA2 in generating Pareto solutions, meaning that the proposed algorithm outperforms NSGA2 with respect to the NPS factor, number of Pareto solutions. MOGASA excels in comparison to NSGA2 in diversification and distribution metrics. Well, actually, in almost all test problems, MOGASA outperforms NSGA2 with respect to space covered measure. This model is capable of providing Pareto solutions, dominating 39% of the solutions generated by NSGA2. So, in conclusion, the new hybrid model is able to provide a set of efficient solutions that are approximated to Pareto solutions. Considering the results obtained by MOGASA and the better solutions, the higher computational time seems rational since the proposed algorithm discovers more space in the feasible area by applying local search. To end this episode, I'd like to admit that it is safe to say that mathematical models towards supply chain and logistics can seem very complicated, but they're actually quite resourceful and accurate. It can be extremely hard to come up with a solution that can cover all of the issues presented, and this model may have its own flaws, but I believe that it can introduce us one step closer to developing new systematic models that can help us with environmental problematics. Reverse logistics is a very powerful idea to control all of the waste that is harming our planet. It should be implemented by everyone, although I think that right now, due to COVID, it may be really complicated. Let's just hope that one day we can all be a part of this and help our planet heal. Thanks for listening, and I'll see you in another episode. Bye!